Okay, we're going to go over this example. It says the height and weight of several adults were recorded. So we have height that represents the x value. We have weight that represents the y value, right? So part A says, what does the slope of the line represent? So first of all, we actually have to identify what the regression line is. So what I've done is I've already typed in our values into the graphing calculator. And then what you do is you click Stat, move over to Calc. Well, just a refresher, just so you know how to type in the values. You go Calc, or sorry, you click Stat, Edit, type in your two lists. All right. And then you click Stat again, you move over to Calc, you choose option 4, and it gives you this value, these values. It gives you y equals ax plus b, where a equals 47.9 and b equals negative 126.63. So that represents our regression. So I'm going to enter y equals 47.9 x, and then our b value is negative 126.6, so minus 126.6. If you're using Desmos, again, you're going to click on the three bars, and then you're going to scroll down until you see statistics, linear regression. You're going to click that, and then you type in your data values, and it gives you the same, right? So it gives you this box, which is really, really important because it gives you the correlation coefficient. In this case, the R value is 0.998. The graphing calculator also gives you the correlation coefficient, 0.998. And then it gives you the slope and the y-intercept. So 47.9, negative 126.63. So 47.9, negative 126.63. So the slope is 47.9, right? So what that means is, remember that the slope is vertical change over horizontal change. In this case, the vertical variable is the y variable, right? So this is, remember we went over this the other day. So this is going to be y over x. But in this case, our y variable, if we go back to the table, is weight, and our x variable is height, right? Looking at the table, we see that the height, if we move down, is increasing, and the weight is also increasing. So this means that it's a positive relationship, okay? If the height was increasing and the weight was decreasing, hypothetically, not in this situation, that's not happening, but if it was, that would be a negative relationship, right? So that's one way to be able to decipher a data table. Okay, so going back to this, vertical change over horizontal change is y over x, which in this case, our variables are weight versus height. And since it's 47.9, that means that it's 47.9 over 1, right? So that means that as the height, since the height is 1 unit, right? As the height increases by 1 foot, because we're in a measurement of feet, the weight will increase. Since the weight is 47.9, the weight will increase by 47.9 pounds. So again, as the height increases by 1 foot, the weight will increase by 47.9 pounds. Okay. Okay, second part. What does the y-intercept of this function represent? So remember that the y-intercept, right, is where the line crosses the y-axis. So what this means is, at this point, x is equal to 0, right? So anytime they're asking for you to describe what the y-intercept is, remember that x is equal to 0, and in this case, the y-intercept is negative 126.6. So x is equal to 0, y is equal to negative 126.6. So now we have the numerical value. So what does this mean? Again, since our x variable is height, right, this means that at a height of 0 feet, a person's weight will be negative 126.6 pounds, right? And since we never have anybody that is at 0 feet, this situation is almost impossible. It is impossible because nobody's ever going to be negative 126.6 pounds, right? This is just following a prediction. It's not an accurate measurement. Okay. Part C, using this model, what would be the weight of someone who is 5.7 feet tall? Okay, 5.7 feet. Since they're giving us feet, we have to remember that based off our original table, feet is our x variable, right? And we have this linear equation that we can substitute our feet for x, right? So if we do that, we get y is equal to 47.9 times 5.7 minus 127. So if I use the calculator, 47.9 times 5.7 equals 273.03. I subtract 127 from that, I get 146.03. So we would expect a person that is 5 feet 7 should weigh, should weigh 146.03, 146.03 pounds. B, according to the model, what would be the weight of someone who is 7 feet tall? Round your answer to the nearest tenth. Well, okay, let's go back to part C. 5.7 feet. Do we have 5.7? Nope, but it's between 5.2 and 5.8. 5.7 should be between 122 and 148 pounds. 146 pounds, since that's between 146 is between 122 and 148, that works, okay? Okay, so now someone that's 7 feet tall, again, they're giving us the height, so we're going to substitute height for x. So we get this equation, y is equal to 47.9 times 7 minus 127. So 47.9 times 7, oops, 47.9 times 7 equals 335.3 minus 127 is 208.3 pounds. So 208.3 pounds for someone that is 7 feet tall. 208.3, do we have 7 feet? No, we have 6.4. 208 is greater than 183, so this works. All right. Okay, part D. No, sorry. Part E. What is the height of someone that weighs 56 pounds? Okay, so since they're giving us weight now, we have to use the weight to find x, right? So 56 equals 47.9 minus 127. So we're going to add 127. So 56 plus 127 equals 183. Divide that by 47.9, and we get 3.8. So someone that weighs 56 pounds should be 3.8 feet tall.